Welcome to the final lesson of Grade 7 Mathematics. This module is a little different. Instead of one new topic, we'll learn how to think, how to reason carefully, and how to solve problems you have never seen before. These are the skills that hold all of mathematics together. Here is our plan. We'll meet the two great kinds of reasoning, then learn Polya's 4 steps for solving any problem. We'll build a toolkit of strategies and learn to find the rule hidden inside a number pattern. We'll touch on simple logic and finish by looking back over the big ideas of the whole year. Mathematics uses two great kinds of reasoning. The first is inductive reasoning. We look at several examples, notice a pattern, and guess the general rule. Seeing 2, 4, 6, and 8, we expect the next term to be 10. That is a sensible guess, but not yet a proof. The second is deductive reasoning. We start from facts we already know and reason to a conclusion that must be true. Since an even number plus an even number is always even, 6 plus 8 is certainly even. Inductive reasoning finds the pattern, deductive reasoning proves it. When a problem looks hard, a clear method keeps us moving. George Polya gave us 4 steps. First, understand the problem. Read it slowly and ask what is being asked and what information we are given. Second, make a plan. Choose a strategy that fits the problem. Third, carry out the plan, working carefully and one step at a time. Fourth, look back. Check that the answer makes sense and that no step was rushed. If it does not work, we loop back, revise our plan, and try again. These 4 steps fit every problem in this course and far beyond it. The second step, making a plan, is easier with a toolkit ready. Drawing a diagram turns words into something we can see. Making a table organizes the numbers so a pattern can appear. Working backwards starts from the answer and undoes each step. Trying a simpler version of the problem first often reveals the method. And guess, check and improve lets us close in on an answer step by step. A skilled problem solver does not know one trick. They choose the right tool for the problem in front of them. A sequence is a list of numbers that follow a rule. Look at 3, 7, 11, 15. The first move worth making is to find the gaps between terms. Each gap is 4, so the rule is to add 4 each time. The next term is 15 plus 4, which is 19. A constant gap means we can write a formula. Here the term equals 4 times its position, minus 1. That formula lets us jump straight to the 10th term, which is 4 times 10 minus 1, or 39, without listing every step. Reasoning rests on logic. A statement in mathematics is either true or false, never both at once. Many rules take the form, if this, then that. If it rains, then the ground is wet. But notice the trap. A wet ground does not prove that it rained because someone may have watered the garden. And to disprove a claim, we need only one counterexample. If someone says all prime numbers are odd, the number 2, which is prime and even, settles it at once. Before we close, let's look back over the whole year. We began with integers, then fractions, decimals, and percentages. We studied ratio and proportion and the powers of numbers. We moved into algebra with expressions and linear equations. We explored geometry from angles and shapes to the coordinate plane. We measured perimeter, area, and volume. And we finished with statistics and the language of probability. Every one of those topics is a problem waiting for the reasoning we have practiced today. This way of thinking reaches far beyond the classroom. A market trader in Kigali watches the pattern of weekly sales to decide how much stock to buy. A farmer counts the yield from one sample field and reasons from it to the whole harvest. Someone saving for a phone works backwards, taking the target, subtracting what is saved, and finding how many months remain. And a health worker checks a claim against evidence before trusting it. Reasoning well is a life skill, not only a mathematics skill. Even careful thinkers fall into a few traps, so let's name them. First, a handful of examples gives a likely rule, but it is a guess, not a proof. Second, an if-then statement does not work in reverse. The result does not prove the condition. Third, read the whole question before planning, so you solve the problem actually asked. And finally, never skip the last step. Always look back and ask whether the answer makes sense. Avoid these four, and your reasoning will stay sound. Here is a summary of today's key ideas. Inductive reasoning finds patterns, and deductive reasoning proves them. Polya's 4 steps are understand, plan, carry out, and look back. When you plan, choose a strategy that fits the problem. For a number pattern, find the constant gap, then write the rule. A single counterexample is enough to disprove a claim. And always look back to check that the answer makes sense. Now, let's put it all together with 3 quick questions. Here is the first question. What is the next term in 2, 6, 12, 20? Look at the gaps, 4, then 6, then 8. They grow by 2 each time, so the next gap is 10. 20 plus 10 is 30, so the next term is 30. Question 2, and now we reason. True or false, every multiple of 4 is even? A multiple of 4 is 4 times some whole number, and 4 is itself 2 times 2. So the result is always 2 times something, which is even. No counterexample can exist, so the statement is true. Last question. A number is doubled, then 3 is added, and the result is 17. What was the number? Let's work backwards. Undo the adding. 17 minus 3 is 14. Undo the doubling. 14 divided by 2 is 7. So the number is 7. Congratulations. You have reached the end of grade 7 mathematics. From integers to algebra, from geometry to probability, you have built a strong foundation, and today you learned how to reason your way through any problem. Keep using Polya's 4 steps, keep looking for patterns, and always look back to check your work. It has been a privilege to learn alongside you this year. Be proud of how far you have come and keep going. I'll see you in your next course.